Please ask people to be quick. I hope that's all. Can we start? Or should we wait? Sure? Yeah. Okay, so now let's continue with the previous problem. When we discussed with the A section, I told there is an issue, we'll just look at it. Is it not, guys? So if the calculation is, no, what is 10 millivolts by 75 microamps?
Yes, ma'am. We got the resistor value very high.
Yes? Yes, Sudhir? It's 133 ohms, right? Am I audible?
Yes, Lord.
Yeah. Please put your phones in silent mode. Okay. And now what is my question is, so we said that VI minimum, R2 is nothing but VI minimum by I2 minimum. What is VI min? 10 millivolts, and I2 min is 75 microamps. So what is the resistance, or what is the resistance value you get? 133 ohms. Yes, the A section guys, they didn't calculate it in this, right? Sudhir? In the morning class? A section students?
Yes, ma'am, we got 133.3.
ಮತ್ತೆ ಬೆಳಗ್ಗೆ ಕ್ಲಾಸಲ್ಲಿ ಸುಮ್ಮನೆ ಇದ್ರಲ್ಲಪ್ಪ. ಮತ್ತೆ ಕ್ಲಾಸಲ್ಲಿ ಸುಮ್ಮನೆ ಇದ್ರಿ. ತಪ್ಪಾಗಿದ್ದಾಗ ಮ್ಯಾಮ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ತಪ್ಪಾಗಿದೆ ಅಂತ ಹೇಳ್ಬೇಕಲ್ವಾ? So now, what is the gain of your circuit? We know what is V0 and what is Vin. So knowing V0 and Vin, can you find out what is the gain? 400. So V0 by Vn is 400. That is 4 volts by 10 millivolts. So you get your gain to be 400. What is the formula for gain? One plus 2R1 by R2. So when it's 1 plus 2R1 by R2, so you know what is ACL, you know what is R2. Can you find out what is R1? $26.53 kilo ohms. Sorry, so the standard value would be 27 kilo ohms. Yes? So we know that in our instrumentation amplifier, we usually R1 is equal to R3. And that's why we took the gain to be 2R1 plus R2 by R2. So R1 is equal to R3 is 26.6 kilo ohms. That is approximately, we take 27 kilo ohms because it's the standard value. So you got around 26.53, right? So this is 26.53 kilo ohms. Make a change in that nodes also. So either you can do it like that or consider your V0 to be 4 volts. And the same voltage is divided across your VR1 and VR2, and assuming the difference is 0, you can do it. Okay? I feel this is better. Obtain the gain, and then using the formula for the gain, you can find out R1, and you know R1 is equal to R3. Okay? So now, coming over here, what is the potential across these two resistors, VR6 and VR7? They have to be equal. So we assume VR6 and VR7 is equal to 1 volts. So when VR6 and VR7 is equal to 1 volts, what will be? 1 second. So if you take VR6 is equal to what is happening? VR6 is equal to VR7. So in this resistance R6 of this circuit, the resistance of this R6 circuit, at least the minimum current will flow. Yes. In the R6, at least minimum current would flow. So what is VR6 is 1 volt. So giving VR6 and VR7 to be 1 volt. So when I take VR6 and VR7 to be 1 volt, at least the minimum current I2 minimum should flow.
Disconnect. Sorry.
Sorry. So when I say VR6 is equal to VR7 is equal to 1, and I2 minimum is the minimum current which has to flow through R6. I2 minimum is the minimum current which has to flow through R6. So what will be the resistance R6? VR6 divided by I2 minimum. So what will be the resistance? That is VR6 is 1 volts and I2 minimum is 75 microamps. So it's again it is 33.2 kilo ohms. Correct? Do you get the same thing?
Yes, ma'am.
What is the standard resistance nearer to this? Twelve kilo ohms. Okay. So 12 kilo ohms is R6. Now, as we said, the overall gain will be produced by the first stage of the amplifier. So the second stage of amplifier is just for unity gain. So in this,
Yes, first page, rest of it.
so here, what are the resistance values for to be one? The gain to be one in your difference amplifier? What should be these resistance values? Or is there any relationship between this difference amplifier? Differential amplifier ಮರ್ತೋಗಿದ್ಯಾ? ಹೇಳಿ ಮತ್ತ. All the resistance have to be equal to have your unity gain. And that means your R4 is equal to R5, which is equal to R6, and the same is equal to R7, which is equal to resistance. What is the value? R6? 12 kilo ohms. Any doubts with this problem? Any doubts with this problem, guys?
No, ma'am.
So take down the next problem and you try it. We'll continue with the next topic. It's a very small topic, so I can do it in half an hour or so. If you're quick, we'll wind it up soon. So note down this problem and tell me. Someone unmute your audio and tell one. Question ಬರ್ಕೊಳ್ಳೋ ಆಯ್ತಾ ಆಯ್ತಾ Shall I start? Okay guys, done? Shall I continue? Yeah, thank you. So next topic in your second unit is your V to I and I to V converters. Sorry, what's the voltage to current converter? We also call that as a transconductance amplifier. So your V to I and I to V converters are also called as your transconductance amplifiers. So what do you mean by this transconductance amplifier or a voltage to current converters? Where do you need such conversions? V to I. So guys, when your current is transmitting, your current becomes difficult. Yeah, I can say your current carrying signals are more prone to noise compared to your voltage signals. The other way around, I can say is it is easy for you to transmit the voltage signals from the transducer devices than the current signals. So we go for using your voltage to current converters. So this can be used in your instrumentation amplifiers also, where you require a voltage to current conversion. So when I say it's a voltage to current conversions, it can be done in two ways. One is your V to I converter with a floating load, and the other one is your V to I converter with a grounded load. Okay. So your voltage to current converter with floating load and voltage to current converter with ground load. Now let us consider this circuit, which is your voltage to current converter with a floating load. So when I say it's your voltage to current converter with a floating load, now can you analyze this circuit? So this input voltage given in the non-inverting terminal, it appears at the inverting terminal also. Alright? Yes or no? Now try to analyze this circuit. What happens at node VA? What is the voltage at the node VA? Or the other way around, if you take VA to be equal to V1 and apply KCL, apply KCL at node V1. So it is VI by R1 plus what happens again? VI minus V0 by Z or the load. So at node voltage I can say VI is equal to V1, that is also same as VA. So if you observe here, whatever the current which appears at this resistance R1, whatever the current which appears this resistance R1 is the same as the current which is flowing through the load, because your op amp will not take any current. Is it not? Your op amp will not take any current, so whatever the current which is flowing from R1 to is same as the current which is flowing through R2. So I can say your input voltage VI is same as the load current IL into R1. So VI is equal to IL into R1. So what is IL? Is equal to VI by R1 with your floating load. So you can see here the input voltage, whatever I am applying to the non-inverting terminal, is converted into the current at the output terminal of your op amp. Is it not? So whatever your input voltage is converted to the output current of your op amp circuit. Since it's your op amp will not draw any current, so when it doesn't draw any current, whatever the current is there in the load is the same current which is going through R1. So what is the significance here? So to say that this input source, whichever provides VI, should be capable of handling the current IL. Is it clear? This VI should be capable of handling the current IL. So if you observe here, it is your simple non-inverting circuit with Vin being the input given to the non-inverting terminal. When I see that here, since your op amp is not drawing any current, whatever the current is through ZL is same as the current through R1. So the output voltage would, the input voltage is nothing but your load current into R1. So your load current IL would be VI by R1, that is same as your output current. Is that clear? Any doubts with your V2I converter with a floating load? Yes. This ZL value is floating, where ZL value is not connected to ground. Usually all your load resistances or load impedance would be connected to a ground, right? This is not connected to ground, so we say that it's a floating load. That's it. So the next one comes your V2I converter with a grounded load. You can see the circuit here. Your V2I converter with a grounded load. Sorry, I have not written the name of the figure. Now, this is your VI. So now let us try to analyze this circuit, which here you can see your load is grounded. In the earlier case, your load was not grounded. That's the difference. Or I can say that's the major difference why we call your V2I converter the floating and a grounded load. So let us assume V1 is your voltage at the node A. So in general, I can say V1 is equal to V A. Now apply KCL over here. What happens? IL is equal to I1 plus I2. Then you apply KCL at node A. So what is I1? VI minus V1 by R. And what is I2? V1 minus V0 by R, which is equal to our load current IL. Now try to represent it in, now find out the expression for V1 voltage. Find out the expression for V1 voltage, simplify it and tell me what is the expression for V1.
So ma'am, I2 will be V0 minus V1 by R, no ma'am?
Yeah?
I2 will be V0 minus V1 by R.
Yes, that's what I wrote. No, Vi minus V1 by R and V1 minus, say V0 minus VA.
V1 by...
Put it in the same direction for both. Otherwise it's wrong, correct. Good. V0 minus V1 by R. So can you tell me what is V1? That is your potential at node 1. Vi plus V0 minus IL into R divided by 2. Is it correct? No. So now you know what is the voltage V1. That is the voltage which is appearing at the non-inverting terminal. What will be the gain now of this non-inverting terminal? So what will be the gain of this circuit? Gain is equal to 1 plus R by R, because both the resistances are equal, is it not? Say this is your RF and this is your R1. Both RF and R1 are equal to R, so I get the gain to be 2. Correct? Because your op-amp is operating in non-inverting mode. So now, what will be the output voltage? Gain into input which is appearing at the non-inverting terminal. Which is the input voltage which is appearing at the non-inverting terminal?
V1.
V1. So, what will be the final expression for output voltage? Vi plus V naught minus IL into R. Correct? Correct, Ann? 2 gets cancelled out. So now if you observe, V naught exists on both the sides, even these gets cancelled out. So my expression reduces to Vi is equal to IL into R. So if we simplify it further, the current IL is equal to Vi by R. Here also you can see the source current, source input current is converted into the load current flowing through your circuit. Is that clear? Any doubts? There are many other V2I converters, but what is the advantages of it? Again, it has input impedance in non-inverting mode, and thus I can say a non-inverting amplifier has a high input impedance, and thus we get a proper conversion. Any doubts with this? As the input impedance of a non-inverting amplifier is very high, this circuit has an advantage of drawing very little current. Yes, guys, any doubts? So let us see some of the these applications are low voltage DC and AC voltmeters. These V2I converters can be used, and it can also be used in LEDs and Zener diode testers. Okay, these are some of the applications where your V2I converters are used. So you can look into several papers which works on V2I converters with all these circuits. Okay. Any doubts about V2I converters? Everybody, is it clear?
Ma'am, how did we get that?
Which one?
Can you tell us?
Which one?
Substitute from two. Substituting from 2
2 is nothing but your expression for voltage V1. This is what we have obtained here. This is your V1, and this V1, I have substituted it here.
That denominator 2, how did it come, ma'am? Like,
You didn't solve this.
okay, yes, ma'am, understood.
You have to solve this so you get it. So when you solve this, you get, I think I have done the intermediate stages over here. See, Vi plus V naught minus 2Va or Va is equal to V1. So Vi plus V naught minus 2V1 is equal to IL into R1. So I bring 2V1 to the other side and the rest all to one side. So I get 2V1 is equal to Vi plus V naught minus IL into R1. And then I bring the 2 to the denominator. I think you haven't solved this part, right?
Yes,
From here to here.
Got it, ma'am.
Yeah. From here to here, you get this 2, and the gain of the op amp is 2. So since the gain of the op amp is 2, when I multiply this with the input, 2V1, 2 gets cancelled. Correct?
Yes,
Yes or
ma'am.
no? Now it's fine?
Yes, ma'am. Thank you.
Okay. Thank you. Any other doubts? Any other doubts, guys? Thank you. So shall I proceed with the current to voltage converters? So again, where do we use these current to voltage converters? So whereas your photocells, photodiodes and photovoltaic cells gives you an output current which needs to be converted into an voltage. So it gives these photocells, photodiodes or photovoltaic cells gives an output current which is proportional to the incident radiant energy or light. So whatever the energy or the light falls on the photodiodes, that will be in terms that will be reflected through the photodiodes through the output current. So these currents need to be converted into a potential. So when these currents need to be converted into a potential, we need to have a current to voltage converter. So what is the significance of this current to voltage converter? Which makes it easy for your measurements basically. So this is your high to V converters. Okay. So currently consider only this much. So now if you observe, as we all have seen in the op-amp circuits, whatever the current which flows through here, the same current will flow through the feedback resistance RF because the op-amp is drawing, the op-amp draws the current which is 0. The op-amp draws a current which is 0. So what will be your output voltage? And we know it's in the inverting amplifier and this is at virtual ground, so this is at 0. So now, what will be the current? Now, can you find out what is the current IS? The current IS the same as V0 minus the virtual ground point, or the other way around. Since the current is moving away, we will take it V. I call this as node A. So IS is equal to VA minus of V0 into RF. What is VA? What is the potential? It is 0 minus V0 by RF. So what will be our output voltage? V0 is equal to minus IS into RF. Since I've used the low uppercase representation here also I use it and also modify it over here. That is IS. And both these currents are equal, so IS is the source current IS when it is multiplied with the resistance RF, which will give me the output potential. This is the voltage which is proportional to the current source. Is it not? This is your output voltage which is proportional to the current. Right? Any doubts with this I to V converter? Is it not very simple? Current flowing through I to V converter, since we have the negative terminal to be get the output voltage. So the same current flows, so the output voltage is nothing but the source current into the feedback resistance. So what is the minimum current which can flow here? I said we have a current to voltage converter. The minimum current depends upon the bias current of the op amp, which will be given in the data sheet. Okay? Any doubts still here? Now, at high frequencies, there might be some oscillations introduced in the circuit. So to avoid these oscillations introduced in the circuit, your RF is shunted with the capacitance CF. To avoid the high frequency noise and possibility of oscillations. To avoid the high frequency noise and possibility of oscillations, we go for using the capacitance in feedback. As I said earlier, the applications are photodiodes and photovoltaic cells, that's your photodetectors, and also we use it in DAC to convert your current to voltage. Any doubts? Any doubts, guys?
No, ma'am.
Alright, thank you. So with this, we complete the current to voltage converters and also your voltage to current converters. Meanwhile, just try to solve this problem. For the V2I converter shown in figure, R is equal to 10 kilo ohms, Vn is 5 volts and V1 is 1 volt. Find the load current, and output voltage. Find the load current and output voltage. So just think over how you can solve this problem. Just think how this problem can be solved. As we know that let us take your op amp doesn't draw any current. So IB is 0. So this is your V2I converter with grounded load. This is your V2I converter with grounded load. Your V2I converter with grounded load. So again, you can use the formula directly, or we can take IL is equal to I1 plus I2 and solve for this expression for load current. And what is the gain here? As we discussed earlier, your gain is 2. And it's given that your V1 voltage is 1 volts. So what will be V0? Two into V1 whereas our V1 is 1 volts, so output voltage is also equal to 1. So now we know V1 is 1 volt and Vin is 5 volts. Can you find out IL? Can you find out the load current IL? What is the load current IL?
0.2 milliamperes.
0 point. Be loud and clear.
0.5 milliamperes.
Yes, your load current would be 0.5 milliamperes and the output voltage would be 2 volts. Is it not? So if you want, you can note down the solution. I assume you all have done. Any other doubts with this? Any doubts, guys?
No, ma'am.
Okay. With this, we complete our second unit. Okay. So if you guys have any doubts, we will discuss. Else we'll wind up today's class and we'll start with a new unit from next class. Is there anything else we need to discuss? ಹೇಳಿ ಸಂಜಯ್ ಏನಪ್ಪ ಏನಿಲ್ವಾ ಓಕೆ ಓಕೆ ಥ್ಯಾಂಕ್ ಯು
Thank you.
Okay, thank you all then. So Sanjay, make sure if there are any slots, Sanjay and Sudeep, if there are any slots where you guys both are free and even I am free for extra 1 hour session because I am lagging too much behind. Yeah, thank you. Because daily lateral entry students are missing this Saturday session. You guys are sending the recorded one?
Ma'am, today no class, ma'am, for lateral students.
Okay. So you all are there then. Okay. Thank you. So work out for a better timings or else we'll fix it to Saturday 2:30 to 3:30 every week. Okay? Because I don't want any of you to have issues. Or we can take it from 1:30 to 2:30 also. I don't mind.
1:30 to 2:30 we have not having M2 classes, ma'am. It's better, I think, every Saturday.
Okay. So you will be free all the time. Saturday is 1:30 to 2:30. Alva Karan?
Yes, ma'am.
Okay na ಎಲ್ರಿಗೂ?
Ma'am, 1:30 lunch time, ma'am. Ma'am, 2:30 to 3:30 okay because ನಾನು ಮ್ಯಾಮ್ಗೆ ಹೇಳಿದ್ದೀನಿ ಮ್ಯಾಮ್ 3:30 ಆಫ್ಟರ್ 3:30 ತಗೊಳ್ಳಿ ಅಂತ. ಮ್ಯಾಮ್ ಓಕೆ ಅಂತಾನು ಹೇಳಿದ್ದಾರೆ ಮ್ಯಾಥ್ಸ್.
ಎವ್ರಿ ವೀಕ್ ಹೇಳಿದಾರಪ್ಪ?
ಎಸ್ ಮ್ಯಾಮ್, ನಾನು ಹೇಳಿದ್ದೀನಿ ಮ್ಯಾಮ್.
ಏನ್ ಕರುಣ್?
ಮ್ಯಾಮ್ ಅವ್ರು ಹೇಳಿದ್ದಾರೆ ಅಂದ್ರೆ ತಗೋತಾರೆ ಮ್ಯಾಮ್.
ಸೊ ಹಂಗಂದ್ರೆ ತೊಂದ್ರೆ ಇಲ್ವಾ 2:30 3:30? ಆಯ್ತು, ನೀವೆಲ್ಲ ಡಿಸ್ಕಸ್ ಮಾಡ್ಬಿಟ್ಟೆ ಹೇಳ್ರಪ್ಪ. ನನ್ನ ಎದುರಿಗೆ ಡಿಸ್ಕಸ್ ಮಾಡಕ್ ಆಗಲ್ಲ ಅಂದ್ರೆ. So the other students, sorry, the other students don't have problem with 1:30 to 2:30. Right? Many? ಎರಡೂವರೆ ಮೂರುವರೆಗೆ ಫ್ರೀ ಇದ್ದೀರಾ? ಹಾ ಹೇಳಿ ಸಂಜಯ್, ಸಾರಿ. ಸ್ಯಾಚುರೇಟ್ ಆಗಿರ್ತೀರಾ ಅಂತನಾ? ಓಕೆ. 2:30 to 3:30 every week. Vishwas, have you discussed with your faculty there?
Yes, ma'am.
So no issues. 2:30 to 3:30, you guys all are free.
Yes,
All
ma'am.
140 students can attend my class. Okay then, fine. Saturday we'll fix it to 2:30 to 3:30 combined class. Okay guys? No issues? Okay.